Okay, this is question number 15 on page 663. Someone had asked some questions about this one, so I will go over it with you guys, even though none of you are here. Cos 2x equals 2 cos x. You want to solve over the set of real numbers, so this means we've got a general solution here. Give the answer to the nearest hundredth, which means that we'll need to use our calculator. And right now we have a cos 2x and a 2 cos x. So we have a double angle formula, but when deciding should this be a multi-revolution question or should we use a double angle formula, because we have that other cos x in the equation, we should use one of our double angle formulas. And since we have three options for cos 2x, we're going to choose the 2 cos squared x minus 1 option, because that option will give us an equation that's only in cos. Now we got a quadratic equation in cos. We're going to move everything over to one side and make it equal to 0. And this is not factorable, so we're going to go to the quadratic formula. Quadratic formula would say cos x is equal to negative b plus or minus b squared minus 4ac divided by 2a, and a of course is 2. And simplifying this gives us 2 plus or minus square root of 12 over 4. And so we can separate this into two equations. We've got the one equation that's cos is equal to 2 plus the square root of 12 over 4, and the other equation that cos of x is equal to 2 minus the square root of 12 all over 4. So what we're going to do is we're going to go to our calculator and type these in. Two plus the square root of 12 divided by 4. That'll give us 1.366. And 2 minus the square root of 12 over 4 gives us negative 0.366. So first of all, on the left-hand side, this is an easy one. This is not possible because the value is bigger than 1 and cos can't be bigger than 1. On the right-hand side, we're going to need to find our reference angle, and we find our reference angle by doing cos inverse of the value, but the problem is this value is negative. And when we find our reference angle, we always have to do a positive value. So I multiplied it by a negative 1 there to get a positive value, giving me a reference angle of 1.196. Then since cos is negative, it will be in quadrants 2 and quadrants 3. So go back to my calculator. I'm going to store this value I just got as x. In quadrant 2, it would be pi minus x. And in quadrant 3, it will be pi plus x. So we get 1.945, 1.946. What were we supposed to round to? The nearest hundredth, 1.95, and in quadrant 3, 4.34. Those are our answers between 0 and 2 pi. Our general solution then, we would have to add 2k pi to each of these. So a couple of places, if we look back, of where we could make mistakes. One is making sure that in your quadratic formula you have a cos x here. Another place, often students will just write x equals and think they've solved it when they've written that part, but you have a cos x there and you still need to find your reference angle. Also, a key point here is finding your reference angle. Make sure you're doing cos inverse of the positive value, because if you do cos inverse of negative 3.366, you're going to get the 1.95, but it's not going to help you find the 4.34. And then finally, reading over the question is to realize that this is a general solution question, so you have to add 2k pi to each of those.